Hi to everyone who's already joined us. We're just waiting a couple of minutes. We're just going to give people more people a chance to join, but we will be starting very, very soon. Thank you. Okay, let's get started. Welcome, firstly, JVM Roundabout number 21. So thank you to everyone who's a regular for your loyal following, and anyone new, welcome. My name is Ben. I run this meetup. My day job is a recruiter in the Java space. So naturally, I wanted to kind of give something back to that community and started this meetup back in 2017. So first thing I want to say is, obviously, if you are watching and you then go onto social media and do anything off the back of this, please hashtag the JVM Roundabout. It really helps us with the following and getting it out there. So tonight we're teaming up, with Intuit, and we're really excited about it. We're talking about building APIs. We've got Varsha and Johan, who you can see, both senior engineers in the business. They're both from different teams, so two different projects they'll be speaking about and perspectives on this. So during this, you can ask questions in the comment section, and then at the end of each talk, I will pick some out to ask. If you don't get to ask, I'm sure the guys won't mind you contacting them afterwards, you know, in private, if there's anything else you wanted to know. So I will hand over firstly to Varsha, who's going to start. And yeah, thanks everyone, and enjoy.
Yeah, thanks, Ben. So I'll start sharing my screen. So I hope you guys can see me okay and see the slides okay. So yeah, thank you all for being here today at JVM Roundabout, and I'm excited to share our learnings from building an API platform within Intuit. So a little bit about myself. So I'm lucky to have had the opportunity to work as a software engineer in 3 different countries in my career, and I'm super excited to see where this tech journey takes me. Currently, I'm a senior engineer at Intuit. And for those of you who don't know what Intuit does, so Intuit builds fintech products to help customers file their tax forms and do small business accounting and also do personal finance management. And so Intuit has been around for about 30 years, 37 years actually in the US, and it has been relatively new to the UK market. So you can imagine when a company has been around for so long, it's super important to constantly re-innovate ourselves and do a lot of innovation within the company in order to focus on the right customer problem. And the way that Intuit has been doing it for the last couple of years is through HIP, which is an internal startup incubator, which helps build new businesses within the company. And my team, FormFly, is one of the first teams to get funded through Intuit for building our own product and a business within the company. So I would like to take you guys 80 years back when humans built their first calculator, actually. And the picture that you see on your left is the memory unit of the calculator, which almost takes up an entire room. And the person that you see on your right is called David Wheeler. And he is the man behind building this calculator. And the reason that I wanted to talk about this today is because this is the first time in history when a complex computer problem was broken down into modules and subroutines. I'm sure when they were doing it, they did not think of it as APIs or two systems communicating with one another. But definitely this has influenced the way that all of us are building APIs today and the way we are thinking about APIs. So that brings us to the definition of API itself, which is nothing but an interface or contract between two systems, between two computer systems for it to talk to one another and get the job done effectively. So before going into the API platform and the features and how we develop APIs itself, I would like to take a moment to talk about the customer problem that we are solving. So if you are a small business owner and if you hire contractors or employees to work for your business, then you have a liability to report what you're paying them to the IRS in the US market. And the way it has been doing currently within Intuit products is Intuit has this backend e-filing engine, which talks to IRS and which also sends the tax forms to the contractors and the workers through physical mail or by email. And what our team came up with the idea is to build a modern API wrapper around the Intuit's e-filing engine, which has been used to file millions of tax forms of millions of users over the years and expose it as APIs to external businesses as well. So any customer, any payments platform or contractor marketplace or accounting software can really use this API in order to build their integration with the IRS, because if they have to build it themselves, they would have to put in a lot of time and energy and resources in order to do that. Instead, they can take advantage of the APIs that we have built. So we started about 20 months back, and so tax year 2019 was the first time that we were live in the market, and we were able to support 5 external enterprise customers file their tax forms through FormFly, and we were also able to support partially 3 internal Intuit products, which is QuickBooks Online, QuickBooks Mac, and QuickBooks Desktop to file their tax forms through the FormFly APIs. And the reason this is important is because this makes us understand how important it is to design the APIs in a generic way. So it solves the problem of any type of products or any customers that is trying to do tax filings with the IRS, instead of solving it specifically for one customer or like one specific use case. As you can imagine, our APIs span across multiple tax years, and we are also trying to expand to multiple form types. We started with one form type last year. So it's super important for the API design to be extensible to support all of these features as well. So let me show you how the product looks like. So this is our documentation website that that a developer can come into and have all the information that they need for building an integration with FormFly itself. You can see the API contracts and other details about the API. And this is our developer dashboard, which is where you can collect the API credentials and also have other information for how your integration is going with our system. So you can have webhooks in order for us to send you notifications about any status changes to the forms, and you can see all the forms that you have submitted through the system, and you can also see the logs of all the API hits you've done. So let's dive more into the different features that our APIs support. So it's very important for developers to have a sandbox environment in order to test the integration itself before they can send in production data or take it live to their customers. And the way FormFly does it is by using auth-based redirection. So imagine a customer hits v1/forms endpoint. Then before we route it to our service layer, our controller automatically reads the auth token and identifies if it is a test token or a live token, and is able to redirect to the respective endpoint automatically. So we use Java and Spring Boot to build our backend service, and we use DynamoDB for our data storage. So that's a little bit about our architecture. So with respect to tax form filing itself, we want to make sure that we don't send duplicate forms to the IRS, both for in order to prevent bad actors by taking advantage of the system, or for also prevent a genuine use case of hitting an API multiple times. So the way we do that is we try to uniquely identify a form by using tax year, payer, recipient, and the original form ID combination. And the way we do idempotency can be implemented in the API in multiple ways, and we implement it using a hash-based idempotency. So our APIs will respond the same way when you hit them, but we would not reprocess the same form that has already been submitted to the IRS. So imagine if you created draft forms using our Forms API, and you're trying to update the form in order to submit it or starting to process with the IRS. Then we have support for HTTP verbs. So you can basically send us the form ID along with the verb, and this will perform the action in the backend of submitting the form, which is more easier for the developer to do instead of sending the entire payload with the specific correction of just making the submit as true. One thing that we try to pay a lot of attention is how we design the resource itself. We want to make sure that we design it in a more extensible way. So because it's impossible for us to know what are all the future use cases. So in this specific example, you're seeing the status object, which currently supports mail and e-file. But imagine if we decide to add email in the future, then it will be easier for us to do so by just adding one more nested object within statuses. And you can also see that the status field itself is an enum. And by using enums and nested objects, it really helps us to design something in an extensible way without having to do breaking changes or rewrite the entire resource very often. Our initial version of Git API would just respond all the data in the system without chunking it out. And we really wanted to add pagination as a feature, mainly to address the performance issue and also to help the end user have a better experience by viewing only chunks of data instead of viewing the entire data at once. And we decided to experiment with two different pagination approach. So one is token-based and the other one is offset-based. So the way we implemented token-based pagination is we use DynamoDB as our data store, like I mentioned before, which already supports bidirectional pagination. So we built a token-based pagination on top of DynamoDB, and that will respond, and we will respond those tokens in our API requests and responses. So user can use that to request specific page of data, and they will be able to traverse through the list by either clicking on previous or clicking on next. So offset-based pagination is actually much simpler than token-based pagination, and the way we do it is by using Spring Pageable out of the box on top of our Elasticsearch data store, which is our secondary data store. And in offset-based, imagine if you have 100 data items, and if your page size is 10, so basically the 100 data items is split into 10 pages, and the user can specifically request a page number, and we will be able to get them the responses from that request. And we also send back some metadata information on what are the total number of pages available and total number of items available that satisfies this specific request. And we decided that we like offset-based pagination more than token-based pagination, mainly because of the simplicity in maintenance from the backend perspective, and also for the user experience of being able to, if they want to go to page number 10, they can just click on page number 10 instead of clicking on next 10 times. So, and the way we decided that is all our APIs, we try to use it internally for our internal dashboard use case, or within internal Intuit products before we expose that to external customers. So that helps us get a quicker feedback cycle within the company, and which helps us adjust the design of the APIs or the implementation flaws before we go live with our external customers. We wanted to add plain text search and filtering capabilities in our developer dashboard, mainly because imagine a customer who filed thousands of forms, and if they want to specifically check the status of a single form, we wanted to give them the ability to do so by searching based on address or name or phone number or anything that they have. So the way we achieved it in our APIs is to have search request parameter, which is basically a plain text which they can put in the value of any fields within the form data. And also the ability to do filtering, which is a list of key value pairs. So this makes it really extensible, and it's not limited to a specific field. So even though currently we support filtering by tax year or form type or even the environment values, like we would be able to extend it to multiple filters because the design already supports for it. Among all the features that we have discussed so far, I would definitely say that error handling is the most important feature for an API, mainly because a developer who is interacting or integrating with our API is super important for them to understand all the different use cases an API could fail, and so that they could handle those in their client-side application as well. And the way we build that in our backend is it's as if we have a validation layer between the controller and service. So all API request which comes through the controller, before it hits the service, it goes through the global validation layer where we have all the validations in one place. So it's easier. So we don't have code spread out in the service layer, which is going to do null checks or like throw an exception or anything like that. So it's all collected in a single validation layer. And to look at how the developer experience looks like for error handling, one of the things that we do in our error handling, we always return a list of errors instead of returning one error at a time. So if there are multiple issues with the API request that somebody sent, it's important for them to know all the errors at once so that they can handle it and resend the clean data. And we also have numeric error code, and you can see the list of all error codes that FormFly would respond to you, which is documented here. So there is no surprises as to the API throwing a different type of error, which you haven't seen before. Another important thing that we often forget is the human in the picture, which is the developer. So it's important for them to easily read and understand why an error is thrown, and should also be self-serve for them to be able to fix it by themselves instead of trying to contact us or like trying to figure it out by themselves. So after the integration, the development phase, the maintenance of the integration itself, like it's very important for developers and the external company to know what is going on with the APIs, and what is the percentage of success, what is the percentage of error. So we show all the logs of the API within the developer dashboard. And as you can see the HTTP status codes, and you can see all the APIs, and you can also do a click down to see a specific request object and the response object along with the header data. And we record it by using Spring interceptors. So at the end of completing an API request, we massage the data the way that we want to store it within our DynamoDB tables, and we store all the important information so that it's both for security purposes and also for customers to be able to debug what's going on with their integration. So having talked about all these features that we have been building and building these APIs for the 20 months now, we really have learned a lot of design principles, which we would like to share with all of you today. So the initial version of API that we designed was actually a batch API, which would take in a bunch of tax forms within a single API request and try to process all the tax form at once. And we actually thought it was a good developer experience, mainly because customers are going to file tax forms at once, so it will be better for performance as well. But we scratched that entire implementation and we redid it with just a single form, with an API which is taking a singular form and processing a singular form. And looking back, the learning that I would draw from this specific instance is it's good for us to start simple and start with lesser features in the beginning, mainly because we have no idea how customers are going to use our APIs or which direction the market is going to pull us. So it's important to be able to be simple so you can easily add the future layers. Because in this case, if we had gone with the batch approach, it would have been hard for us to figure out how to do batch of error handling and also how to do versioning with respect to different APIs hitting different versioning endpoints within a batch, and also different APIs hitting different form types within a batch, and all of that complexities, which would have been complex for us as an implementer, and also complex for the API developer who's trying to integrate with the system. So definitely starting simple with simple CRUD operations and trying to add on additional features as we go would be a nice way to do it. So in all our design discussions, we are all super passionate about the way we design APIs, and we argue about the most small and simple things in our team. And we passionately do that, and we all know that we are not criticizing each other, but we are just trying to bring the best in our API design. And one of the things that we really had a big argument around was if we should break the rest pattern to avoid plural in the tax form naming in our API, or if we should keep the plural. And we decided to avoid plural mainly because of it would be intuitive for a developer who had no idea about the names of tax forms to easily understand by just looking at the URL. So imagine a tax form which is called W2, and if we were to add an S at the end of it, so people could get confused if W2S is a new tax form type or if it's just a plural of W2s. So that's the reason we decided to go with the singular naming. And I'm not trying to advocate breaking rest patterns, but what I'm trying to draw here is doing it consistently across all your APIs. So our APIs should always be predictable for somebody who is integrating with our APIs. So if somebody built an integration with one tax form, it should be super easy for them and straightforward for them to build the second integration with the second form type without having to have so much of a learning curve. And that's why consistency is super important. So like I already mentioned when I spoke about pagination and text search, we try to consume the new features that we develop internally, either in our developer dashboard or within the Intuit products, in order to have a faster feedback cycle and for us to understand how a specific API might be used, and if we have missed out on specific use cases, to redesign it or re-implement the API itself. So this has definitely been a powerful approach for us to design APIs and also take it to external customers. So all the principles and philosophies are always great, but it's super important to know how we are actually bring those principles to life. And that's where our development process is super important. We force ourselves to write API documentation first before even writing a single line of code. And we did not start this way. The first few releases that we did, this process was actually reversed. We started with coding and we would do code review, and then we would write the documentation for the API. But actually reversing the process and doing the API documentation first was something that I learned in one of the Stripe TED Talks that I listened to, who actually learned it from Amazon. So it's basically a concept called working backwards. So you start with the place of what the customer is going to see and what they are going to deal with, and then you try to work backwards from there on how the implementation is going to look like. And the way we do that is by writing an open API schema for our APIs. And we also use Insomnia Designer, which would auto-generate the docs, which is super easy to have design discussions within the team and quickly give peer feedback for the API design itself. So if there is one thing that I would like you guys to take away from this talk, that would be this thing, to start with writing an API documentation before building the API. And the goal of this talk is not only for developers who are building external facing APIs, but also for developers who are building internal APIs which are used by their own companies, which is almost all tech companies. And the reason I'm saying that is because most of the time we don't take our internal APIs with the same seriousness as how we take the external APIs. And it's still important to design the internal APIs in a more consistent and document it in a more consistent way, because even though you might spend more time initially, it would increase the velocity of both the front end and back end teams working with one another, and also increase the velocity of multiple back end teams working with one another. So I would definitely encourage you to try this process and give me feedback on if that worked for your specific team and your experience in doing so. And so there is definitely no secret sauce for building a great API. And if I have to tell one thing, that would just be paying more attention to detail and spending the time to make it right. So that would be the one secret sauce of building a great API. And that's what we learned from building our own platform and would like to convey to you guys today. Thank you so much for taking the time and listening to me patiently. And if you have any questions, feel free to comment. I'm happy to answer questions, or you can also reach out to me on LinkedIn. Thank you.
Hello. Thank you very much, Varsha. That was great. I'm just having a look in the comments. So I think it's actually a couple of your colleagues who have to ask you something here. Srujal Patel, I'm sure you know. Can you see that?
Yeah, I can see that. I'm just reading through the comments right now.
I'll read it out in case anyone is watching but not looking at their screen right now. So my question is, I'm confused about how we should use specific error in API.
Yeah, I think I'm a little, I know it sounds meta, but I'm a little confused with the question itself. So how we should use specific error in API. So I think the API error documentation that I was trying to show was throwing error for different use cases. So having error codes for each of that use case. So it's easier for your API client to handle those use cases. And but I think I don't fully understand the question, so I'd be happy to chat later. Or
yeah, okay. So the next question, again, someone you'll know well, Israel Bethencourt. How the service is operated, monitoring, supporting customers. Has the Intuit platform helped building this new product, or everything from scratch?
Yeah, totally. Yeah, we used MSAS, so which is the internal Intuit's for building the deployment pipeline itself. So we definitely use MSAS for building the new service. So the API layer and how we expose to customers was something that we built from scratch, and the features of the API. But the pipeline, the monitoring, and all of that was something that we definitely used from MSAS. And in terms of supporting customers, we used to create Slack channels, with each of the external businesses that we work with. So we can have, and we used to have all the engineers on the team on the Slack channel as well. So we can quickly listen to the customer's feedback and go implement it in the API itself.
Cool, thank you. Looks like that there's no questions. Someone I know quite well, Enrico Trentin, works for a company called Diff Blue. He wanted to comment just saying great presentation, as you can see. Thank you, Enrico. So yeah, obviously any questions come through for you, Varsha, I'll let you know, but otherwise, thank you very much. Really appreciate it.
Yeah, thank you.
And we'll move on to your colleague, Johan, who is our second speaker. Thanks.
Yeah, thank you.
Thank you. So yeah, I'm Yuan. I'm also a developer in Intuit. And as I learned today, same as Varsha, I've been a developer in 3 countries. So I'm originally Swedish, started my career there, and then I moved to Italy, stayed there for many years, and now I'm here in the UK. And what we'll be speaking about is how is it to develop an application without a framework. So I usually write my code with Spring, and I try to do this application, sample application, without any framework or libraries, and also with Spring. And if I manage to move the slides. So a lot of times I hear about dependency injection and that we need to use Spring and a framework to actually do dependency injection. I don't think that I knew or a lot of other developers know about the routing works in a web application. And these days, we also have the database integration. Do we actually know what SQL statements are running or not? Something that I did know very well when I started developing. So that was the 3 initial questions that I wanted to answer, but also what benefits do we get from using Spring as a framework? And how does Spring or the framework influence how I write my production code or my test code and my way of developing? So that's the things I tried to answer in my project here. I wrote it both with Spring and without any framework, as I said before. So let's start with dependency injection and no frameworks. This is the graph that the dependencies that I have in my application without the framework. As you can see, I have a servlet. I decided to use the Java Servlets libraries. Then I have an event controller. It's a normal controller. I skipped the service in this case that you normally see in an application and went directly to the repository. And then I have my abstraction over the database, which is the holiday database. So the application I wrote was actually how to report holidays to in your company and get an approval from your manager. And this is actually the code that I needed to write in Java 11. As you can see, you have just creating the new instances. I decided to use them as the singleton that you have in Spring. So it's just one instance in the whole application. And this is all the code I needed to write to actually do the dependency injection in the application. And the lessons I learned from doing this without the framework is that I'm more aware of big parameter list constructors. I actually am more aware if I have some object that is depending on a lot of other things, which I think is quite a design smell often. I also relearned that dependency injection is not that hard, actually. As you can see, it's just creating new objects and pass them into the constructor and serve them. It's easy when you can do it like this in the startup of the application. And one of the drawbacks is probably that you will have to change the main class, as I call it, where you create the objects and inject them into the other ones, as every time you create a new class that needs the dependency. You can split that up in different classes and avoid that a bit, but you still have that some place where you actually need to change quite often as soon as you create a new class and bean, as they call it, Spring. So what's the difference in Spring with the dependency injection? I think this is the dependency graph that you have in Spring. You can see my classes is around something that I don't have control over, which is the Spring application context. So Spring application context will actually take care of creating the instances of all your classes and handle the injection, as I guess most of you know. And this is how you specify it in the code, that they are available for injection. And then you can either use the constructor and auto-wired, or you can put it on fields. I really encourage people to use the constructor injection if they use this. One of the things you can see here is actually many ways that you can declare a bean in Spring, like REST controller, service, repository, and component, and other things. And I think with Spring, you actually see it's quite easy to see that you have a dependency injected into the class because you have the Spring annotation with REST controller or service all auto-wired. So you will actually see that these instances are managed by the Spring context, and you will get the dependencies injected, and they are beans. Another drawback with Spring that I notice is that it's really hard to decide in which order you want to instantiate objects, if that is important. Hopefully it's not, but sometimes maybe you have a class that you want to instantiate before, just to get a faster error message if you can't connect to the database. Why create everything and just try to create the instance that connects to the database first, have the check that it goes to the database, and if you can't reach it, stop the application and fail fast. So the routing, without any framework, this is one way that I wrote it. It can see quite long, and you see that on the font size, it's quite small, so you don't see the details. So what I did was to explode one part of this so we can see it. What I decided to do was just, in this example, how I wrote this, you can see that I'm more interested in events, and then I have the other things that can happen on events underneath it. So I could communicate with this code that I want to concentrate on the type, and then I can see underneath what is happening. I tried to play around with this a bit more, and I wrote it in a slightly different way. And this communicates is slightly different. It's less hierarchical, and I can really see in a compact way all the methods and routes that I have in my application. So this, I think, is a good thing. You have the opportunity to implement in different ways depending on what you want to communicate to your fellow developers on the application. And what I decided to use in my application here is something called a front controller pattern from the Enterprise Architecture Application Architecture Catalog by Martin Fowler, which is that you have one controller in the beginning of the application that understands what kind of request is this and calls forward to the correct instance. I found it very easy to control how the priorities are between the routes. So if you have some parts of the routes that are similar between two cases, I can easily decide that this one has higher priority than that one. Same thing here, you have a quite high churn on the routing class because every time you add the route, you need to modify that class, at least in the way I implement it. And as I said, different implementation communicates differently to your colleagues and yourself in the future. So you can decide what's important and not. In Spring, as you can see here, for declaring the routes that you have, you create a request mapping with the events. That's the main path for this route. And then inside on the methods, I can specify exactly the method and the continuation of the path if I want to. And one thing is, if you see here, you have the route very, very close to the implementation. So you can see quite easily how this route is mapped to this logic, at least on the controller level. I find it's always a bit unclear how priorities are between routes in Spring. I know you can do something about it, but it's always something I need to look up if I have that problem. And without any tooling support, it's hard to see what routes you have in your in your application and what's supported, which methods. So tooling helps there, but if it was concentrated in one place in the code base, it would be even easier to find, I think. So another big part of when application that we write is hopefully domain logic and application and not the framework code that I've shown so far. So this is more or less how the flow is in my code. It's quite standard. You have the server, which is actually, in my case, a Jetty server. I have my routing servlet, which handles the dispatching between controllers. And then I have a controller, and then I have my repository, which speaks to my layer on top of the holiday database, or of the database. And this was one part of the code that I have in my example application. I decided to move the parsing of the parameters into the controller. The controller is the one you see on the top. And I create my domain objects, and I use them and store them in the repository. And in the repository, which is the lower part here, you can see that I have a clear understanding of where it will be stored in the database. I managed to create my way to communicate with the database that works well in this application. And you can see some mappings as well from the main objects to the database values. And one thing that I noticed when I wrote this application without the framework is that I actually started more on the domain level and managed to build up the application on the domain first, and then I added on top of that the roots and even the database. I made my application layer on top of JDBC, so I can interact with the database in the way I want to interact with the database and not how some framework forces me to do it. And I also noticed that I were more willing to use design patterns in this way of working than I was when I used the framework. So I had felt that I had more freedom to actually do my code as the code wants to be and not forced by a framework. In Spring, this is what I needed to do. Same endpoint actually as the other one. A lot of the parsing and transforming of parameters to Java objects are handled by the framework, which is always nice. The repository call is automatically handled by the Spring implementation. So I don't need to know how to interact with the database. And the code is actually much shorter. What I felt when I wrote this application is that I felt more forced to follow the standard pattern that we have in a Spring application with the controller, the service, and the repository. It was easier to support different input formats because I don't need to parse it. I tried to do the no framework one with JSON input, and I gave up. I don't want to write a JSON parser. I don't need to write the database queries. I hope that the framework can optimize the queries in a good way. And I noticed that I felt more encouraged to separate the business logic from the data structures. So having a pure, an object with pure only data and another object with a class with the domain logic. So for the testing without the framework, I came up with what I think is a quite legible way to understand how I tested the routing. So the first one on the slash, on the root of the application, I expect just to get the 200 results. I want the response from there. The second one is on Yuan events. I expect to get the response back, an OK, with that JSON back, as you see, and as the last parameter. And I could do it with post and put, and even, as you can see here in the second from last line, I can actually pre-populate the application as well with new things, and so I can actually update an object. Testing the application logic. As you can see, I think it's quite readable. I see that I have, this is more the domain logic. You could argue that if you have this in the same test, it's testing two things. So this is the main logic. This is more on how it's mapped to the database. And yeah, I think this is on the controller level, more or less. So one of the goals and what I wanted to show with the No framework is that I can actually test the routing without starting any server. So it's just pure unit test. I can do the same thing with the database. So I can test my SQL queries more or less, even without starting up the database. I can actually see that I'm calling a SQL statement and I'm passing the right parameters. I noticed that I used a lot less mocks, not only because I didn't want to use the library for mocks, but it felt more natural actually to test it without mocks in this way. And testing with Spring. Since the repositories in Spring are just an interface, it felt much more natural to actually, okay, if I want to test my service, I need to add the mocking framework, so let's use it everywhere. And that's what I did. So this, I guess, is a quite normal test with a mock. You can see I call the controller for get all the events for me, and I assert that I get the two objects back as I say from here. Also with Spring, you probably can, but it feels unnatural to test the routing without loading up the application context and let Spring, the framework of Spring, actually handle the routing and see that you call the correct controllers. But you need to load the application context in some way. If I want to test more on the SQL test with the Spring framework and the repositories that Spring supplies, I actually need to start up some kind of database. And it was much simpler to set up data in the Spring case because of the mocking and the support from the framework. So my conclusion is that when I used No framework, I felt that the data and the logic in the application felt more natural to actually stay together and be full objects, as I call it, and not separation between a data class and a logical class. It's easier to find all the roots. It's more painful when the dependencies change, because I actually need to go and not only create a new class and add an annotation. I actually need to go somewhere else to create the object and make sure that it's injected in the right places. It was really hard to support different input formats, but it should be quite easy to add a library to parse, for example, the JSON input that I gave up on. And I think you also need more general knowledge. It goes back to using more patterns, especially for the framework code, like the routing, know about the front controller, know how, if you go on that way also for the database, maybe you want to know how to implement a unit of work that is quite common in all API implementations. And as I said, for Spring, it felt much more natural to separate the logic from the data structure. For sure, it's a lot more magic. I have a hard time sometimes to actually understand why this happens in Spring. Repeating again, it's no central place for finding the routing information. I feel that bad design is actually less visible with Spring, especially because if you take the class that have a lot of dependencies, you just add a thing to a constructor and you create a new object, and you don't need to care about it much more. Here it was an addition, without the framework, it's an additional step that you actually need to do, which makes it more, I felt more, that I became more aware about a lot of dependencies in one class. I used more mocks. Mocks can be good. They can be overused. But yeah, it's also a matter of personal taste. And for sure, I need more knowledge about the framework. If you want to stretch the Spring an application written in Spring, you actually need to know a lot about the framework to make it do the things that are not really natural to do in the framework. And then you have a lot of things are easier if you use Spring, like input formats, output formats. Don't need to think about that. You don't need, you can add interceptors, as Varsha mentioned, for handling auditing and stuff like that. And it's much easier to interact with the database for sure, but you also lose some control over the integration with the database and other frameworks. So I think that's it. So I'm open for questions, if there are any.
Very much, Johan. Great talk again. Yeah, there's again a colleague of yours, Israel Bethencourt. How would you decide the balance between using a framework or building everything from scratch in a new app?
So I think it depends a lot, especially on the people that you are in the project and how long it will live and everything like that, and a bit of hiring as well. So I don't think it's an easy question to answer. I just want people to be aware about a lot of things that we actually get from a framework is quite easy to build. So when I started 20 years ago or something like that, you didn't have Spring. You had to build everything like that yourself. So I hope that I have some knowledge. It's not that hard to build a dependency injection framework. I want people to be aware how to do it and what's happening under the hood. Same thing with the routing and stuff like that. But I think it's a lot up to the team, hopefully, and maybe the organization to see, are we willing to actually do this, and in my way give a bit more freedom to the developers and actually try to have a bit more fun. So I think it was much more fun to build without the framework than with the framework, because I felt less constrained. I needed to think more, which is something I actually like to do. But it's a hard balance between should we go with what a lot of people know? Most developers, Java developers, they probably knows about Spring. And if you do your own framework, or if you will end up in the long time, you actually need people to learn about that. But I don't think it's an easy answer to that question. I just want people to be aware and have that question, and then decide in the team if they want to try it out or not. And all decisions are reversible. It's just a matter of how long it takes to reverse them.
Cool, thank you. Looks like that at the moment there's no other questions unless anything comes through. Again, sometimes people may reach out directly or think of something later on, and obviously for both yourself and Varsha, I'll let you know if anyone gets in touch. But thank you to both of you, both speakers, brilliant. And Intuit in general, there's quite a few watching, so thank you to all of you for helping put this together. Obviously, thank you to Beth, my colleague, who works really hard getting these events in place. And yeah, we are running another JVM Roundabout, but this is our last one of 2020, not a year to forget really, but 2021 is hopefully a better year for all, and I'm sure we'll start running them again physically in offices, we hope, and I have no doubt we'll collaborate with some of you guys from Intuit again. You can all probably see I'm wearing a jumper that says the Roundabouts on it, because that's our general meetup brand. So if you go to the roundabouts.co.uk, you'll see all 7 of our meetups, JavaScript, testing, Agile, DevOps, and more. So this isn't the only one we run. So just keep an eye on that. But yeah, I just want to thank the speakers again, Beth and everyone at Intuit. January the 21st is penciled in for our next one. That's with a company called Diff Blue. Diff Blue are a company based in Oxford, but obviously this is an opportunity for them to run one because we're doing it virtual. And yeah, have a great evening, everyone, and thank you again.
Yeah, thank you so much.
Thank you.